Quantum physics theory, high-tension heliospheric magnetic field. In the context of the quantum physics theory, the heliosphere is not merely a region of plasma and solar wind, but a complex intersection of carrier space field force dynamics. The relationship between the high-tension heliospheric magnetic field and the theory's core postulates can be summarized as follows. Field-driven structure. The heliosphere's magnetic boundary acts as a localized high-tension node within the broader carrier space field force, influencing the local tension potential. Gradient modulation. Rather than viewing the magnetic field as a separate force, the theory treats it as an observable gradient within the space field's tension fabric. Navigator's calibration. When a vessel traverses the heliospheric boundary, the navigator's console must calibrate for the specific high-tension resonance of this magnetic region to maintain a stable gradient-pure state during transposition. By mapping the heliosphere as a high-tension gradient, the theory allows vessels to navigate through these areas by matching the ship's internal resonant frequency to the specific tension signature of the magnetic field, avoiding the need for traditional inertial propulsion. Would you like to explore how the navigator's console differentiates between the magnetic tension of the heliosphere and other high-tension nodes, such as galactic cores during a transposition? Hemispheric magnetic field. In the quantum physics theory, the heliosphere magnetic field is interpreted through the lens of the carrier space field force. Rather than acting as an isolated phenomenon, it is viewed as a high-tension node within the broader tension fabric of space. Key interactions regarding this field include tension gradient. The heliospheric magnetic field manifests as a localized region of varying field strength, functioning as a high-tension node that influences the surrounding space field. Navigator calibration. During transposition, the navigator's console must account for the specific resonance of the heliosphere's magnetic tension to ensure a gradient-pure state is maintained. Field mapping, because the theory views these magnetic structures as tension gradients, they are mapped as topographical peaks within the carrier space field force, allowing for precise navigational adjustments. Would you like to examine how the navigator's field tension console differentiates the specific tension signature of a heliosphere compared to a galactic core? To differentiate the heliospheric magnetic field from more intense high-tension nodes like galactic cores, the navigator's field tension console employs a multi-tier resonance analysis. Resonance signature filtering. The console identifies the heliosphere by its characteristic mid-range oscillation pattern, which is significantly less dense than the high-frequency harmonic peaks found in galactic cores. Field topology modulation. The system uses the field topology modulator to normalize the ship's internal resonance against the heliospheric magnetic gradient, ensuring the vessel maintains its gradient pure state without being affected by local magnetic flux. Topographical tension mapping. By measuring the local tension gradient, the console can distinguish between the relatively stable plateau of heliospheric magnetic tension and the steep, jagged potential peaks that define a galactic core's topography. Because the heliosphere is effectively a lower tension environment compared to a galactic center, the console adjusts the ship's transposition vector to follow a flatter trajectory, preventing the drag that occurs when crossing higher density space field regions. Would you like to see how the console displays this topographical difference on the bridge interface? Or should we examine the risks of failing to calibrate for a galactic core's high-tension surge? The quantum physics theory and its application to space travel. The primary concepts illustrated include Kawecki postulate. This principle states that gravity is not a particle effect, such as gravitons, but is instead an intrinsic tension potential of the carrier spacefield force. Carrier spacefield force. This represents the underlying fabric of space, which is mapped as a topographical terrain to facilitate navigation. Gradient pure transposition. Ships utilize this method to move through space without the need for inertial coupling. Navigator's field tension console. This equipment allows navigators to map tension gradients, identifying potential peaks, high tension nodes like galactic cores, and potential valleys, low tension voids, to perform precise transpositions. Active gradient perturbation. By utilizing a nuclear singularity, a vessel can create a decoupling field to enter an inertialess state for travel. Would you like to know more about how the navigator's console specifically handles the transition from a high-tension galactic core to a low-tension intergalactic void? The navigator's console specifically handles the transition from a high-tension galactic core to a low-tension intergalactic void. To handle the transition from a high-tension galactic core to a low-tension intergalactic void, the navigator's console performs several critical functions using the carrier spacefield force. Field topology modulation. The console utilizes the field topology modulator to adjust the vessel's resonance, smoothing the transition between the extreme potential peak of a galactic core and the surrounding space. Gradient pure transposition. The system facilitates a jump bridge across the tension gradient, allowing the ship to bypass standard inertial movement while navigating from high tension node to a low tension void. Sensor calibration. The carrier force. Tension sensors continuously monitor the slope of the space field, ensuring the ship's trajectory is aligned to move from a potential peak down toward a potential valley. Grid anchoring. As the vessel nears the destination, the console recalibrates the current grid anchor to the stable conditions of the intergalactic void to finalize the transposition. This process effectively manages the ship's energy state relative to the surrounding space field, ensuring a stable jump without the need for traditional mass-based interactions. Would you like to know more about how the nuclear singularity generator creates the initial perturbation required for this transition?